Well, let's take a look at this problem involving average value of a function in section 5.4. So it's wanting us to approximate all points on which the given function is equal to its average value for f of x is equal to pi over 14 sine of x on 0 to pi. So the first step is you need to go ahead and find the average value. Average value of a function is 1 over b minus a, so 1 over pi minus 0 on the integral from 0, well, in general, on the integral from a to b of f of x dx. In this case, that's 0 to 4, 0 to pi of pi over 14 sine x dx. We know that the integral of sine is negative cosine. So that's why I have the negative pi over 14 cosine x here. Of course, the coefficient just became 1 over pi. Then we need to evaluate this from 0 to pi. What I went ahead and did is simplified my two coefficients. The pi canceled out, and then I was left with negative 1 over 14 after that. I'll have that negative 1 over 14 multiplied by the product of the cosine of pi minus the cosine of 0. Well, we know that the cosine of pi is negative 1, cosine of 0 is 1. So that's where this next step came from. Our average value of the function is negative 1/14 times negative 2. So that ended up giving me 2 over 14, which reduced down to 1/7. Now, we need to find the values of x such that f of x is equal to this average value. So that's where I did this. I just went ahead and set the original function from the problem equal to this value that we know is the average height of the function from 0 to pi. So we know that there's some values between 0 and pi such that that height occurs. Okay. In order to simplify for the angle x, I got rid of the coefficient, multiplying the reciprocal on both sides. That gave me that the sine of x was equal to 2 over pi. Now, I had to think, well, okay, where at on the unit circle could this be? So I went to my calculator and I did 2 over pi, and 2 over pi is approximately 0.637. So that told me that I need the y component on the unit circle to be approximately 0.637. I know that that occurs in quadrant 1. It also occurs in quadrant 2. That is when the sine could be that 2 over pi at this angle x1 or at this angle over here that I'm calling x2. Now, the only way we can find the correct angle for that, since this is not one of the common angles we're supposed to be familiar with on the unit circle, is to go in and take the inverse sine of both sides and say that x1 is going to equal the inverse sine of 2 over pi. But please remember, the restriction on that is that the inverse sine is only capable of giving you an answer between negative pi over 2 and pi over 2. So my calculator is only capable of giving me x1. I have to get x2 from logic. So I get the x1 from the calculator and say just the inverse sine of 2 over pi. We'll see that I did that right here. Inverse sine of 2 over pi. I got 0.6901, which rounds to zero point 0.7. Now, I almost made a mistake as I did this problem. To get to the other angle, I wanted to just say pi minus that answer I got of zero point 0.7. But that introduces too much rounding error because you'll see that that would give me rounded to what they want, just one wimpy decimal place. That would give me 2.4. That's not the answer that they want. So to get the other answer that they want, you're going to need to say, well, let's find the exact value first, then round that answer to one decimal place. So the other answer, we know that if you have to rotate zero point 0.7 radians to get from the x-axis to where the sine is 2 over pi, then you're going to have to rotate that same angle here from pi to x2. So that's pi minus the angle I found right there. Well, that angle is the inverse sine of 2 over pi. On the calculator, I did pi minus the inverse sine of 2 over pi. That would give me approximately 2.45. This problem only wants us to round to one decimal place. I get the 2.5. Okay, guys, hopefully that helps you out on this one.